Slant asymptotes, pre-college math. So we've discussed vertical asymptotes, domain, holes, horizontal asymptotes to this point. So step number 7, after you do all of that, is to state any slant asymptotes the rational expression may have. So when no horizontal asymptotes exist, and we did horizontal asymptotes in the previous lecture, and we learned that there were 3 scenarios of horizontal asymptotes. It could be top heavy, bottom heavy, equal power, and they meant different things. Whenever it was top heavy, meaning the top exponent was larger than the bottom highest exponent, that was considered top heavy. That meant that there was no horizontal asymptote. Well, it turns out that in a top heavy scenario, there's definitely no horizontal asymptote, but there may be a slant asymptote. But it only exists in a specific case. It only exists if the numerator power is exactly 1 power higher than the denominator. A slant asymptote exists. So, for example, see like how in this problem here, our power on top is x cubed and the power on the bottom is squared. That means that this is top heavy by exactly 1. This is a case for a slant asymptote. And so we're going to have to find the slant asymptote. If you come across a question that's like, say, x to the 5th over x squared, this is definitely top heavy and there's no horizontal asymptote. But because this isn't by 1, this is larger by a factor of, there's 3 more, right? 5 is 3 more than 2, not just 1 more than 2. Because this isn't exactly 1 higher, that means there's no slant asymptote either. So it's not necessarily that every time it's top heavy it's slant. It has to be top heavy by exactly 1 higher. So this will not produce a slant, but this will. So how do we do that? Well, first of all, it would start off by recognizing that it's top heavy and there's no horizontal asymptote. But it is top heavy by exactly 1, which means there is a slant asymptote. And the way to get the slant asymptote is doing long division. So the equation of the slant asymptote is the quotient. Remember, quotient is the result after division of the numerator divided by the denominator, and any remainder is irrelevant. So here comes long division again. So what we do is we recognize it's top heavy by exactly 1, right? This is 2, and so it's larger than 1, and it's exactly 1 larger. So now we're going to do long division. So x squared minus x minus 2 is being divided by x minus 1. And if you remember your long division, this will be easy. X squared divided by x is x. Distribute it to x minus 1 gives you x squared minus x. Change your signs, combine. I end up with 0 here, 0 here. All cancels out. All I'm left with is bringing down a minus 2. Minus 2 cannot be divided by x minus 1, and so that's actually it for this problem. Your slant asymptote would be y equals x, which is the quotient up here. The remainder is negative 2, but it's irrelevant, so we don't really care what the remainder is. We don't care if it divides evenly. All we care is what we get up here. In this case, it's simply y equals x. Now, how did we know to stop? You can't divide unless it has an x. Like if this was x minus 2, then we would divide again. But because it's just minus 2, you can't go any further than that. Let's do another one. So of course there would also be, the vertical asymptotes in domain and holes and stuff like that. But let's just focus on the slant for the video, and then we'll do all of it in class. All right, horizontal asymptote, top heavy, no. Top heavy by exactly 1 higher, so that means yes, there is a slant asymptote. All right, and this would be our SA. And it's y equals whatever you get up here. So doing the long division here is the top divided by the bottom. The top is x cubed, but notice that there are holes. Remember when we did long division and synthetic division that it had to fit perfectly like every exponent. So if there's a missing term like a 0x squared, you want to write that in, and a 0x minus 8. You got to have all of those terms when you're doing division. And if you're doing synthetic division, it'd be 1, 0, 0, and negative 8. The reason why, you probably all believe that synthetic division is a little bit easier, and it is, but synthetic division is easy when you're dividing by something like x minus 1 because your solution would just be 1. But for this problem, I'm dividing by x squared minus 5x plus 6. I can't really do synthetic division unless it's something simple like a binomial. So long division is kind of our only choice here. Now this one has all of its pieces, so x squared minus 5x plus 6. And we divide. So x cubed divided by x squared is x, right? It's just always the front divided by the front. X cubed divided by x squared is x, and then you distribute this x to your term out here, the divisor. X times x squared minus 5x plus 6 is x cubed minus 5x squared plus 6x. Change my signs. Change, change, change. Combine. This cancels out to be 0. 0x squared plus 5x squared is 5x squared. 0x minus 6x is minus 6x, and bring down my minus 8. Now, I can keep dividing because I have an x squared that can be divided by an x squared. So 5x squared divided by x squared is 5. So plus 5. Distribute that 5 throughout. Gives me 5x squared minus 25x plus 30. And what I'm doing is I'm distributing that 5 by all three of these terms. Change the signs. Down here, change, change, change. What's left? Cancels. Negative 6, positive 25 is 19x. And negative 8, negative 30 is minus 38. And I am done. The reason I know I'm done is because this is x to the first, and so I can't divide it by x squared. And so once you get down to something with a exponent smaller than x squared, then you know you're done. And so what that means is this is my quotient. My slant asymptote is y equals x plus 5, the term up here. And this would be the remainder, but we don't care about it. It's irrelevant, so it doesn't matter what's left over. So that's your slant asymptote. It only comes up if you're top heavy by exactly 1. So it's kind of rare. Like when we get it, we'll do a bunch of them for practice tomorrow. But when we get into the graphing, this will come up 1 every 5 or 6 problems. It's not something that comes up every problem. So often, if there is a horizontal asymptote, then there is not a slant asymptote. Sometimes there's neither. So it's a very specific case that this comes up, and it does require some long division, which we've done in the past, but it's probably one of our trickier things that we've done. So we'll definitely practice this tomorrow. See ya.